Morning, my fine young Procyon Lotors, the crepuscular creatures called teenagers. Today I want to cover some physical properties. They were on the classroom wall, so if you were ever bored and weren't texting and you were looking up and to your left, they were across the top of the classroom, if you remember a thing called a classroom. So we're going to look at density and the two sort of quantitative things we're going to play with in chemistry. And what I want you to be able to do is use the terminology on this list, compare and contrast two properties, like be able to say what's the difference between malleability and ductility. I want you to engage in a detailed and mathematical discussion regarding density, which if you've completed the assignment you already can, and explain the property of thermal expansion in detail both qualitatively and quantitatively, and you're going to be able to walk around your world and look for evidence of thermal expansion and density if you're allowed outside without a hazmat suit. Okay, malleability. It's built right in the word. Mallet, meaning you can hammer it. Doesn't mean you can turn into Thor, right? Thor is not malleable. He's quite hard, right? So malleability means you can hammer it and it doesn't get destroyed. So gold is very malleable. Glass is not. Silly putty, I would hesitate to say malleable because it's not really a solid. So generally when we say malleable, it's a solid. So pure copper, pure gold, you could take a hammer to them and flatten them out into a really big sheet. In fact, gold is so malleable, you can hammer a sheet of gold till it's only a few atoms thick and it holds itself intact. Ductility means you can stretch it into a wire without breaking it. Copper is very ductile. Glass, of course, is not ductile. Duct, it's kind of hard to see here, means to lead. Aqueduct, air duct, tear duct. It leads you somewhere. So it's kind of like a cartoon character when you grab the guy by the bow tie and stretch it and then he comes following. So ductile just means you can lead it somewhere. You can stretch it and it does not mean it goes back to the way it was. That's elasticity. So ductile means you can stretch it into a wire. Viscosity is the thickness, how syrupy it is. Water is low viscosity, honey is high. Viscosity is stated in your world in quantitative terms, very vague ones, but oil. So 10W30 oil for a car. 10W, the W either stands for winter, weight, or warm, depending on who you are. But basically is, the higher the number, the thicker the oil. So 10W30 means it's a viscousness of 30 when the engine is cold and a viscousness of 10 when the engine is warm. Because you know yourself, right, butter, syrup, things like that, they get thicker when cold. So car oils already state right on it, the cold to the warm viscosity of the oil that the engine's designed for. Hardness is not strength. Hardness is the ability to scratch something else. There are people that are quite disappointed to discover how easy it is to destroy a diamond ring. A diamond ring may be able to scratch glass, but if you take a hammer to diamond, it will shatter quickly. In fact, many hard substances are brittle. One of the tricks of Japanese sword making was to combine hardness so the sword could have a sharp cutting edge, but leave it flexible. Elasticity means it will go back to its original shape. Rubber bands, diving boards. The biggest problem with elasticity is since we have a thing called an elastic band, most people tend to think of elastic material as like rubbery material. But a diving board is definitely not rubber. Okay? So elasticity is not necessarily a picture in your head of elastic bands. It's any material that returns to its original shape. Now there's a limit. You bend that diving board enough and it will not go back to the way it came from. Brittleness, they crack when they're pushed on. Glass is hard, but it's brittle. It's hard to scratch glass, but it'll break very easily. None of these definitions will you ever be asked to define it on its own. You'll just compare two of them, like malleable and ductile. Now, density is the only one that we're putting a formula to. And you can sort of say this, how fluffy something is. How much does it weigh in a given sized chunk? So lead is very dense, styrofoam is very fluffy. And if you say to me how fluffy or compact something is, that's good enough. Memorizing a formal definition from a textbook does not internalize it to you. If you tell me density in your own terms, and this is why I'm using terms like fluffiness, right? The concept is easy to understand if you use your own terms. If you give me a definition like density is the derived quantity when you measure the atomic mass combined of a sample of a substance in a specific given volume, say grams per cubic centimeter. You could memorize that and still not understand at all. But if you say fluffy and compact, I'm like, okay, you're getting it. Transparency. Transparent means the image goes across. You can see right through it. Translucent means light gets through, but no images. Now, interestingly enough, the name Lucifer, which Hollywood has, it's always, anybody called Lucifer is the devil. Lucifer means the light bringer, right? So it's actually a good name. But since there's one particular Lucifer who decided to sort of like turn to the dark side, the name Lucifer is now referred to like, call your kid Lucifer, watch a movie, it's not going to go well. And opaque won't let light through. And an opaque is a cross between a llama and an alpaca. The word is pronounced opaque. Okay? Opaque, no light gets through. Electrical conductivity, we've already kind of done. If you're a conductor for electricity, you'll let electricity through. Resistance is the common term as well. It's the opposite of conductivity. Copper is very conductive, rubber is not. It's an insulator. Superconductors are awesome, cool things that have no resistance at all. Thermal conductivity, you got a good bet that if it lets electricity through, it'll let heat through. Almost guaranteed. There are some exceptions, but silver and copper let heat through really quickly. So if you stir a coffee with a silver spoon, in a matter of seconds, you're going to be going, ow, 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 at the other end of the silver spoon. And it's a phenomenally good conductor. Styrofoam will slow the conduction of heat down quite a bit. And spacecraft need enormous amounts of thermal insulation to prevent them from being incinerated on the way in. And it's still not a guarantee. There, unfortunately, one of the shuttles did incinerate on the way in. Your house has lots of thermal insulation to protect it from the weather outside. So thermal conductivity and electrical conductivity are actually related. Now, Graham the Indestructible is a video I want you to watch. And it's a first principles design, meaning what would something look like when I design it to survive certain things? Like if you decide to do an army tank and said it must be able to withstand a 88 millimeter high explosive shell at a range of 1,000 yards, and then you calculate how much armor you would need. You are actually using science to make the design. And if you do something like that, you would never, ever, ever build the Death Star because it's a really bad design for what it's supposed to be. So you start with the theory, then you create something with the properties you desire. Okay? Making windows survive an armor-piercing round. All right? The requirement would determine your design from theory. So this is more like engineering. Someone says, I want you to build this. And then you have to go backwards, and you sometimes come back going, there is no such material. We can't build the bridge the way you want it. Now, Graham is a human being designed to survive a car crash. So some scientists went out and tried to show people that won't belt up in a car what you would really need to look like to walk away from car wrecks. And so they redesigned a human being so he could survive a car crash. And those of you who like science fiction and fantasy will really like Graham, because this is how you design an alien, say, to survive on an acid world or something like this. My youngest daughter is drawing dragons from a book, and so the tree climbing dragons, she added those little extra fingers on the wings like bats have, figuring that a dragon that could climb trees would have extra little claws on its wings. So that's a great example of first principle design, and you're all really good at it when you're little kids. You really do a good job that way. And so please watch Graham the Indestructible in the links below, because he is awesome. And here's some examples of how coins are made, picking up a gold bar, a gold vault, and a scene from Goldfinger. And again, I'll put the links below, and I want you to watch them so you can get an idea on this. Now, this one here, the Fort Knox myths, is good to watch. And Thunderfoot is a chemist who runs a science channel. His explanations are beautiful, and he shows in steps how you can take classroom knowledge and use it in the real world. He makes excellent comparisons and uses quantitative data to support his explanations. You can really learn a lot from Thunderfoot. He's one of the better YouTube channels out there. However, as a teacher, you know, and teachers are supposed to be like, we think Mr. Rogers' Neighborhood gets a bit carried away. He swears more than I'd like. He can be very critical to the point of insulting other YouTubers, and he attacks feminists and religion in many of his videos. All right? He's entitled to his free speech. But if you are really sensitive about religion, be careful. You might be offended by him. My take on that is everybody in this world has different opinions. You should be willing to listen to them, even if you disagree. I just want you to know this. If you explore other videos in his series, I'm just showing the one on gold because it is absolutely excellent learning. I personally think he's wasting his time when he goes on social things like feminism and religion. So I would say those videos are irrelevant to our course. But when he stays on chemistry and physics, his work is absolutely marvelous to watch. So please watch these videos.